Welcome back to the next set of videos. This is now moving on to the product rule. The product rule we know has a couple of different forms because there's functions of x. So there's functions of x multiplied by functions of x. So this means that we invoke the product rule. Product rule we saw. Now the way that I do this is y dash equals u dv plus v du. At school, it's often taught to have the same format as the quotient rule, which means v du plus u dv. Often, though, the derivatives are written first. Okay, they mean the same thing. So, provided you go about doing those things, that's fine. U dash and v dash exist in either side, so it doesn't matter. Okay? So y is equal to u v. Alright, so u dv, u is equal to x squared plus 1, u dash is equal to 2x. V is equal to minus 3x squared plus 2x. Therefore, v dash will be equal to minus 6x plus 2. So the calculus is already done. Now we're just formulating gymnastics and putting it into the form that is suitable. Okay? So we've got our UV products. So that's fairly straightforward. UV products. And so we can go ahead. Now I think we did this one before, but not bother at all. Okay, so we can do this one over here. 2x times v. 3x squared plus 2x plus v dash. Use your brackets carefully, and u is x squared. It doesn't matter. Okay? So when you go and do your expansions, you get minus 12x squared plus 4x minus 6x cubed. Sorry, that's a cube. And x squared times 2 is plus 2x squared. So finally get minus 12 cubed minus 6 cubed minus 18 cubed. Plus 2x squared plus 4x. You're done. Okay, same thing. Apply your u, v. Follow which convention you like. That's fine. No problem doing that. And so we can get u dash is equal to 36, 48 actually. What are 48? 48 x 3, taking 1 off, minus x becomes negative 1. V dash will become 4x plus 5. So then you take the four terms and combine them, this one or this one, you'll end up with the same thing. So I'm going to go do it this way. 12 x4 minus x, 4x plus 5, plus 2x squared plus 5x by 48x cubed minus 1. So you can see there's pretty big expansions. So you've got to take care. Notice the detail. Okay, as you put these together. So 12 fours again, 48. x5 5 12s, 60, x4, minus x times 4x is minus 4x squared, minus 5x. That's that expansion done. 2x squared times 4 is 8x. 8x v dash, v was 2x squared, 4x plus 5. That one was 12x4 u v dash, 4x5 v u dash. 48, sorry, I left the 48 out. 48 x cubed minus 1. So 2x squared times 48 will be 96. Wow. x5, 2 and 3. x5, 2 minus 2x squared. 5 48s. Wow. 250 minus 10. 240, is that right? 5 48. 5 8s are 40, 4 5s are 20, 260. 5 8s are 40, 5 4s are 24, 240. That's right, that's what I said. Okay, so 240, 5x times is 240x squared. x3 and x is x4 minus 5x. Wow. A lot of algebraic gymnastics, isn't it? And then you put in the terms together, the 4s, the 5s, the 2s, and the single terms. So 48 plus 240, 48 plus 96. Dear, oh dear. 6 and 8 is 14. 10, 14, 144. x5. Go. 60 and 240 is 300. There you go. Minus 4x squared minus 2x squared is minus 6x squared. So that's out. Minus 5x minus 5x is minus 10x. Okay, so there's your final result for that one. And we just keep going with them. Okay, doesn't matter which way you do it, it's fine. So I'm going to let you use technology. Am I? Gotta keep going with them. That's fine. All right, u, v. So u dash is equal to 3 minus number 3ex squared. V dash is going to be equal to minus 2 4s are 8x. So we're going to group the 4 of those down in C. So y dash will be equal to one of the rules again. One of the rules. Okay. So u dv, I just do it based on convenience. U dv plus u dv v du. So it's good practice on your algebra. A lot of expansions do though, again. So 3x times 3 is 9x. 3x times minus 3ex squared is minus 9ex cubed. The next one's minus 3ex cubed. And the last one's plus 3e squared x5. So that's the last one there. Then we've got 2 3s of 6. Then we've got 2 minus 3s of minus 6, ex squared, and minus 12x squared, and the final term is plus 12 ex4. And I'll let you simplify that as a final answer. Okay. And then for D, U, V, so U dash will be 25. Wow. V dash will be equal to minus times minus comes out the front plus. So we're getting 1 over R6 and plus half minus is minus a half, so it's 2 the square root of R. So I'm being a bit cheeky there, making you unpack those. So the calculus is done. That's the hard part. You've got to do all the steps. Okay, and then you can put them together in their product form. So P dash will be equal to U to V plus V to U. If you choose to do it that way, 25R plus 1 times 1 on R6 plus 1 over 2 root 1 over 2 root R. That's that expansion plus V minus 1 over R5 plus the square root of R times U dash, which was 25. So then you just do the expansions and you'll get them out. Okay? Expansion, expansion. So that's a fortuitous one, it's only 2. Alright, so finish those off. I'll let you do E, and that's fine. Alright, similar kind of thing for our quotient rules. Our quotient rules rely on us using quotient rule itself. So we have a function in the form of a quotient. Okay, then we're going to use the U dv minus v du over v squared. Okay. So let's see if we can put them straight in. Okay, so we've got u dash, u and v. U dash would be 2x. So it would be 2x times v, 1 minus 2x, minus v dash. V dash is simply minus 2. So put it in a bracket, times u, x squared. Minus times minus is a plus. 1 minus 2x all squared. So what do we get on the numerator? 2x minus 4x squared plus 2x squared over the 1 minus 2x all squared. So minus 4 apples plus 2 apples is just 2 apples over 1 minus 2x squared. Even if we take a 2 and an x out, we'll still have a plus. So there's probably no point doing that at this stage. Alright, let's do it again. U, V, and see if we can't put it straight in. Y dash is going to be U dash, which is 3, times V, 6x plus 5, minus V dash, which is 6, times U, all over 6x plus 5 all squared. So doing the expansions, 3 6s are 18x plus 15 minus 18x plus 42 all over minus 18 plus 18, so 42, 52, 57 over 6x plus 5. Okay. Little ones like this are not worth the product rule. Why? Because there's no R here. Where's the R? In a sense, it's not in that form. So let's just bring the R up. So a bit of pre-work. 5R to the minus 3. So y dash would be equal to minus 15. Minus 3 minus 1 is minus 4. Okay, so there's that one. Now we're back to equation. Oh, look, here's a number. So u, v. Okay, so 7 minus 3x. So what's u? Let's see if we can put it all in. Y dash. So we're after u dash. Minus 3. Then v. 5 minus 6x. Minus b dash. Minus 6. U. All over 5 minus 6x all squared. Do the expansions, bit about minus times minus makes a plus here, so be careful. So we've got minus 15 plus 30x plus 42 minus 18x over the bracket squared. So we get minus 30, 30x minus 18 is near enough to minus 20, so it's 12x. And 42 take away 15, 32 take away another 5, 27 over 5 minus 6x all squared. Okay, so some of them are more difficult than others. Look at this, E, so it's not a UV. Strictly speaking, it's not a UV. Okay, so there's no point us doing that in that way. Okay. Okay, but I'll let you just work out how would you do that. You could do it with equation rule, but it'd be pointless because the number would disappear. You'd only get 2 terms. I suppose we could do it for fun, but you could bring this minus 2x cubed up, couldn't you? So this would be pre-work, be e squared bracket 3 minus 2x3 minus 1. Then you'd have to use a u substitution. So we would have to go let u equal 3 minus 2x3 and the u the x is equal to minus 6x. Meanwhile, y would be e2 times u to the minus 1. So dy to u will be equal to minus e squared 1 over u squared minus 2. So putting them together, you'll get minus 6x e squared over 3 minus 2x cubed all squared. Now if we'd done that with the UV rule, we would get exactly the same, and I'll let you choose to do that. Okay. Alright, so what else have we got? F. So for F we can do u and v. U dash will be equal to 3 minus 3x squared plus 7 pi x 6. V dash will be equal to minus 8x. So those four go together then in the form of y dash So y dash will be equal to u dash, which is quite a big term, isn't it? 3 minus 3x squared plus 7 pi x6, all in brackets, multiplied by b, 2 minus 4x squared, subtract minus 4 minus 8x, and the other one is 3x to the numerator. Okay, and all of that is over 2 minus 4x all squared. Okay, so that's ready. Do the final reconciliation for that, and you'll get your f. Okay, which is fairly straightforward. I'll let you finish that off. So again, you get into the practice. This is why I do want to overemphasize them. I feel as though once you start doing the calculus on these, you realise that it's 6x minus 14x minus 3. That's the calculus done. 3x squared plus 2x plus 1. That's the calculus done. So then you're putting in your equation form. So y dash is equal to, again, v to u or u to v. So what are we looking for? V dash. So let's put it in u dash v minus v dash u, v squared. So we're getting quite big products. 6x minus 14x minus 3. V was x3 plus x squared plus x minus, and this is just the numerator. Okay, quite a big pair of products, all divided by x cubed plus x squared plus x all squared. So you can see there's a lot of algebraic gymnastics in there. Okay, so I'll leave you to fill in the dots with those. That's fairly straightforward, I think. You can put this into technology, differentiate. It'll still do it. It'll still work. Okay, as your check. So I'm happy for you to do that. U and v, u dash. Remember that u now is 2x to the power of half. So 2x to the power of half requires a chain rule. Okay, so u is equal to that. So du dx. Now that problem there is that we can't differentiate that easily unless we do something like put the halves in, which I'm okay to do. So it'll be the square root of 2 and the x to the half, which would be a probably easier thing to do. So we'd have a half out the front, so it'd be root 2 on 2. Half minus a half is negative half. So that beats root 2 on 2 root 2. There you go. So they're going to cancel. So that's going to be half. U dash. Root 2 x, I should have said. No, that's not right. So let's go back and refashion that. Let's just, so you've got to take your time. 2 root 2. Put the, let's just not do the differential there. Let's do the differential in the next. Let's do the rewrite. Now take my own medicine. Pre-work if you like. So we're going to do root both of them. Root 2 and root x. Okay. Now we can do. So I really should take that off. And say that was pre-work on u. So now we can do u dash, which would be root 2 on 2, well, that's a half, x is 2 minus a half. So that's root 2 on 2, 1 over square root of x this time. So it'll be root 2 root x. So that's our u dash. And v dash is simply minus 6. So anytime there's a chain rule, it's going to get a bit interesting. Okay, so for this one here, we're going to get y dash is equal to root 2x, starting off with the wrong thing. So there's a little bit of menagerie, root 2 root x times v minus 6 times 5 times root 2x. And all of that is divided by 5 minus 6x all squared. Okay, so you're going to do an expansion on this one. This is going to be 6 root 2x. I might just finish this off for you. So we're going to do the expansion. This whole thing has to be expanded across 5 and 6x. So we'll get 5 root 2 over 2 root x minus 6x root 2 over 2 root x. Minus times minus is a plus, plus 6 root 2x over 1, all divided by 5 minus 6x all squared. Whew, so there's quite a little bit to do there. Okay. And so we get 6 root 2x to simplify that, minus 6 root, we can't do it because they're not the same family. There's no point pretending that we can do that in the same family. I think we're fine there. I suppose one way we could think about this is stretch this out a bit further. Could make this I could rationalise this top denominator, but you know what? I'm going to leave it like that. I think this is one of those things where it takes up your time and we wonder why. All right, so we're going to leave it there. De-emphasise that to some degree. I can finish that off, but I don't want to. I don't want to because I want to emphasise the following work. Back soon.